Let us discuss on the topic neural network. So we already know what is a network. Network is nothing but a collection of interconnected nodes. And now artificial neural network. An artificial neural network is an information processing paradigm that is inspired by the way biological nervous system such as the brain process the information. It is composed of large number of highly interconnected processing elements which is otherwise called as neurons working in unison to solve specific problems. Artificial neural networks like people learn by example. An artificial neural network is configured for a specific application such as pattern recognition or data classification through a learning process. Here let us see the architecture of a simplified neural network. Each neuron has an internal state of its own. This internal state is called the activation or activity level of neuron. Activity is the function of the inputs the neuron receives. The activation signal of a neuron is transmitted to other neurons. A neuron can send only one signal at a time, which can be transmitted to several other neurons. So here we have the input as well as your output. So the input has been specified as x1, x2 and the output is specified as y. The input given to the node x1 is x1 and for x2 is x2 and each node which is connected by the link are assigned an weight. To depict the basic operation of a neural net, consider a set of neurons say x1 and x2 transmitting signals to other neuron y. Here x1 and x2 are input neurons which transmit signals and y is the output neuron which receives the signal. The input neuron x1 and x2 are connected to the output neuron y over a weighted interconnection links w1 and w2. The net input has to be calculated in the following way, where y in is equal to x1 w1 plus x2 w2, where the input neurons x1 is multiplied with the weight. Since the output neuron y is linked with two input neurons x1 and x2, we have to multiply that x1 with w1 and x2 with w2, and the summation of both two will be the input of y in. The architecture of a simplified neuron network, where x1 and x2 the activations of the input neurons x1 and x2, that is the output of input signals. The output y of the output neuron y can be obtained applying the net input, that is the function of the net input y is equal to f of y in. So, therefore the output is equal to function of net input calculated. The artificial neural network characteristics are: it is neutrally implemented mathematical model. There exists a large number of interconnected processing elements called neurons in an artificial neural network. The interconnection with the weighted links hold the informative knowledge. The input signals arrive at the processing elements through connection and connection weights. The processing elements of the artificial neuron have the ability to learn, recall, and generalize from the given data by suitable assignment or adjustment of weights. The computational power can be demonstrated only by the collective behavior of neurons, and it should be noted that no single neuron carries specific information. The next is the learning methods and taxonomy of artificial neural network. The learning or training is a process by means of which a neural network adapts itself to a stimulus by making proper parameter adjustment resulting in the production of desired response. So the learning in artificial neural networks are the parameter learning and structured learning. The parameter learning updates the connecting weights in a neural net, and the structured learning focuses on the change in network structure, which includes the number of processing elements as well as their connection types. So in learning methods and taxonomy, it is generally classified into three categories such as supervised learning, unsupervised learning, and reinforcement learning. First, let us see about the supervised learning. So here each input vector requires a corresponding target vector which represents the desired output. The input vector along with the target vector is called training pair. The network informed precisely about what should be emitted as output. During training, the input vector is presented to the network, which results in an output vector. This output vector is compared with the desired target output vector. Similarly, what the teacher teaches and in our school days. So someone is there to supervise us, and if we haven't received the target, then again and again they will be training us to get the required output. So supervised learning belong to that category. If there exists a difference between the two output vectors, then an error signal is generated by the network. This error signal is used for adjustment of weight until the actual output matches the desired target output. In this type of learning, a supervisor or a teacher is required for error minimization. Hence, the network trained by this method is said to be using supervised training methodology. In supervised learning, it is assumed that the correct target output values are known for each input pattern. And supervised learning. The input vectors of similar type are grouped without the use of training data. To specify a member of each group looks or to which group a number belongs. In the training process, the network receives the input pattern and organizes these patterns to form clusters. When a new input pattern is applied, the neural network gives an output response indicating the class to which the input pattern belongs. If for an input a pattern class cannot be found, then a new class is generated. It is clear that there is no feedback from the environment to inform what the output should be or whether the outputs are correct. In this case, the network must itself discover pattern regularities, features, or categories from the input data and relation for the input data over the output. While discovering all these features, the network undergoes changes in its parameter. So this process is called self-organizing, in which exact cluster will be formed by discovering similarities and dissimilarities among the objects. Reinforcement learning. This learning process is similar to supervised learning. Here only critic information is available, not the exact information. The learning is based on the critic information is called reinforcement learning, and the feedback sent is called reinforcement signal. The reinforcement learning is a form of supervised. The network receives some feedback from its environment. However, the feedback obtained here is only evaluative and not instructive. The reinforcement learning has an external reinforcement signal are processed in the critic signal generator, and the obtained critic signals are sent to the ANN for adjustment of weights properly so as to get better critic feedback in future. The reinforcement learning is also called learning with a critic as opposed to learning with a teacher, which indicates supervised learning. The evaluation of neural network. So the evaluation of neural network was McCulloch and Pitts neuron in 1943. It was designed by McCulloch and Pitts, and here the arrangement of neuron is combination of logic gate. Unique feature is threshold. In 1949, Hebb network was discovered by Hebb. Here, if the two neurons are active, then their connection strength should be increased. From 1958 to 1960, we had the perceptron Adal line, which was designed by Frank Rosenblatt, Bloch, Minsky, and Papert, Woodrow, and Hoff. Here the weights are adjusted to reduce the difference between the net input to the output unit and the desired output. In 1972, Cohen self-organizing feature map was designed by Cohen. The inputs are clustered to obtain a fired output neuron. From 1982 to 1987, the Hopfield network was designed by John Hopfield and Tank. It is based on fixed weights which can act as associative memory nets. In 1986, backpropagation network was designed by Rumelhart, Hinton, and Williams. Here it is multi-layered, and the network is error propagated backward from output to the hidden units. In 1988, counter-propagation network was designed by Grossberg. It is similar to coherent network. 1987 to 1990, adaptive resonance theory was designed by Carpenter and Grossberg. It was designed for binary and analog inputs. 1988, a radial basis function network was designed by Broomhead and Lowe. Here the network resembles backpropagation network but activation function used in Gaussian function. In 1988, neocognitron was designed by Fukushima for character recognition. So an artificial neural network are specified by three basic entities in the basic model, namely the model synaptic interconnection, the training or learning rules adopted for updating and adjusting the connection weight, and their activation function. So first let us see about the connections. Here the connections, the neuron should be visualized for the arrangements in layers. The arrangement of neuron to form layers and the connection pattern formed within and between layers is called the network architecture. And here we have 5 different types of neuron connection architecture. The first is a single layer feed-forward network, multi-layer feed-forward network, single node with its own feedback, single layer recurrent network, and multi-layer recurrent network. The single layer feed-forward network, here the layer is formed by taking a processing element and combining it with other processing elements. Practically, a layer implies a stage going stage by stage. That is, the input stage and the output stage are linked with each other. Don't have any intermediate layers, so it is known as single layer. These linked interconnections lead to the formation of various network architectures. When a layer of the processing node is formed, the inputs can be connected to these nodes with various weights, resulting in a series of output, one per node. Thus, a single layer feed-forward network is formed. The next one is multi-layer feed-forward. So here we'll be having an input layer, hidden layers, and output layer. Here we have two hidden layers, which is otherwise known as intermediate layers. So here the input layers are connected with the hidden layers and the hidden layers are connected with the output layers. We don't have any feedback, that is the output will be given as input to the hidden layer or input layer. So it is known as a multi-layer feed-forward network. The input layer is that which receives the input, and this layer has no function except buffering the input signal. The output layer generates the output of the network, and the layer that is formed between the input and output layers is called hidden layer. This hidden layer is internal to the network and has no direct contact with the external environment. It should be noted that there may be 0 to several hidden layers in an artificial neural network. More the number of hidden layers, more is the complexity of the network. This may, however, provide an efficient output response. In case of fully connected network, every output from one layer is connected to each and every node in the next layer. A network is said to be a feed-forward network if no neuron in the output layer is an input to a node in the same layer or in the same preceding layer. On the other hand, when outputs can be directed back as input to same or preceding layer nodes, then it results in formation feedback network. In feedback network, if no neuron in the output layer is an input to a node and in the same layer or preceding layer, it is known as feed-forward network. If output are directed back as input to the processing element in the same layer or preceding layer, then it is known as feedback network. If the output are directed back to the input of the same layer, then it is lateral feedback. Recurrent network are networks with feedback networks with closed loop. See here, we have the feedback networks. So we have the input and the output. The output is given as input to the input node or neuron, so which is known as single node with own feedback. The next one is competitive nets. So in competitive nets, the output is given as input to the previous node, as well as the weight of all interconnected nodes will be same. Here we have specified it as epsilon, which is known as the competitive nets. Okay, then a single layer recurrent network. Here the input is given, the input layer nodes are neurons are connected with the output neurons, and the output of the output neurons is again feedback to the input of another output neuron. So this is called a feedback network, that is single layer recurrent network. Next one is the multi-layer recurrent network. So here in multi-layer we will be having intermediate layers, and similar to single layer recurrent network, here the output of the output layer will be given as input to the hidden layer, and again it will be processed. Here the processing element output can be directed back to the nodes in the preceding layer, forming a multi-layer recurrent network. The processing element output can be directed to processing element itself or to other processing element in the same layer. Here we should know about the activation function. The activation function is applied over the net input to calculate the output of an artificial neural network. The information processing of a processing element consists of two major parts, the input and output. An integration function, say f, is associated with the input of a processing element. This function serves to combine activation, information or evidence from an external source or other processing elements into a net input to the processing element. The nonlinear activation function is used to ensure that a neuron's response is bounded. Certain nonlinear functions are used to achieve the advantages of a multi-layer network from a single layer network. There are several activation functions. Those are the identity function, binary step function, bipolar step function, sigmoid function and ramp function. The first one is the identity function. It is a linear function and can be defined as f of x is equal to x for all x. Here the output remains the same as input. The input layer uses the identity activation function. Next one is the binary step function. This function can be defined as f of x is equal to 1 if x is greater than or equal to the threshold value theta, and 0 if x is less than theta, where theta represents the threshold value. This function is most widely used in single layer nets to convert the net input to an output that is binary 1 or 0. The next is the bipolar step function. This function can be defined as f of x. So the f of x will be 1 if x is greater than or equal to the threshold value theta, and minus 1 if x is less than theta, where theta represents the threshold value. This function is also used in single layer net to convert the net's input to an output that is bipolar, which may be of positive or negative. So if it is positive, it will be plus 1, and if it is negative, it will be of minus 1. The next one is sigmoidal function. The sigmoidal functions are widely used in backpropagation nets because of the relationship between the value of the function at a point and the value of the derivative at that point, which reduces the computational burden during training. The sigmoidal functions are of two types, binary sigmoid function and bipolar sigmoid function. The binary sigmoid function is logistic sigmoid function or unipolar sigmoid function, which is defined by f of x is equal to 1 divided by 1 plus e to the power of minus lambda x, where lambda will be the steepness parameter. The derivative of this function is f dash of x is equal to lambda f of x into 1 minus f of x. The range of sigmoid function is 0 to 1. And in bipolar sigmoid function, the function is f of x is equal to 2 divided by 1 plus e to the power of minus lambda x minus 1, where lambda is the steepness parameter and the sigmoid range is between minus 1 and plus 1. And the derivative of this function can be f of x is equal to lambda by 2 into 1 plus f of x into 1 minus f of x. Next one is the ramp function. The ramp function is defined as f of x is equal to 1 if the input x is greater than 1, and the x if x is less than or equal to 0 to less than or equal to 1. If the x ranges between 0 to 1, then we have to specify it as x, and if x is less than 0, then we have to specify it as 0. Next important function are the weight. The weight contains information about the input signal. It is used by the net to solve the problem. It is represented in terms of matrix and called as connection matrix. If weight matrix W contains all the elements of an artificial neural network, then the set of all W matrices will determine the set of all possible information processing configuration. The artificial neural network can be realized by finding an appropriate matrix W. The weight encodes long-term memory, and the activation states of network encodes the short-term memory in a neural network. Next one is the bias. Bias has an impact in calculating net input. The bias is included by adding x to the input vector x. The net output is calculated by y in j is equal to summation of I is equal to 0 to n xi wij, where xi is the input and wij is the weight. Now we have to add the bias to what we have in y in j. So now y in j is equal to bj plus, where bj is the bias, and bj plus summation of I is equal to 0 to n xi wij. The bias is of two types, the positive bias and the negative bias, whereas the positive bias increases the net input and the negative bias decreases the net input. Threshold. It is the set value based upon which the final output is calculated. The calculated net input and threshold is compared to get the network output. The activation function of threshold is defined as f of net is equal to 1 if net is greater than or equal to the threshold value theta, and minus 1 if net is less than theta, where theta is the fixed threshold value. Next is the learning parameter. The learning parameter is denoted by alpha, and they control the amount of weight adjustment at each step of training. The learning rate range from 0 to 1, and which determines the rate of learning at each step. Next is the momentum factor. Its convergence is made faster if a momentum factor is added to the weight updation process, and it is done in backpropagation network. The vigilance parameter, which is used in adaptive resonance theory ART network, it is used to control the degree of similarity, and it ranges from 0.7 to 1 to perform useful work in controlling the number of clusters. And we have the application of neural networks. We have many areas in the application of neural networks. Some of them are air traffic control, the animal behavior, appraisal and valuation of property, betting on horse races, stock markets, criminal sentencing, complex physical and chemical process, data mining, cleaning and validation, direct mail advertisers, eco patterns, economic modeling, employee hiring, expert consultants, fraud detection, handwriting and typewriting, lake water levels, machinery controls, medical diagnosis, music composition, photos as fingerprints, recipes and chemical formulation, traffic flows, and weather prediction. So here the book that I used to refer the artificial neural network are J.S.R. Jung, C.T. San, and E. Mizutani, Neurofuzzy and Soft Computing by Pearson Education. The second author is S.N. Sivanandam and S.N. Deepa, The Principles of Soft Computing, and Ville Publications. Thank you.